Alright, so in this problem, I have 32 to the power of x plus 5 is equal to 5. So to solve this, I obviously want to find the value of x. So for my solution, I'm going to start by rewriting my equation. So I have 32 to the power of x plus 5 is equal to 5. Now 32, I'm going to rewrite as 2 to the power of 5. So now I have 2 to the power of 5 to the power of x plus 5 is equal to 5. And if I have something in the form a to the power of m to the power of n, this is going to equal a to the power of m times n. So 2 to the power of 5 to the power of x plus 5, that's going to equal 2 to the power of 5 times x plus 5. And this is equal to 5. Now, I'm going to go ahead and take the log on both sides. So I have log 2 to the power of 5 times x plus 5 is equal to log of 5. And if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So log of 2 to the power of 5 times x plus 5, I can move 5 times x plus 5 to the front. So this is going to equal 5 times x plus 5 times log 2 is equal to log 5. Now I'm going to divide both sides by 5 times log 2. So then these two cancel out, and I'm left with x plus 5 is equal to log 5 over 5 times log 2. And now, if I subtract 5 on both sides, I get x is equal to log 5 over 5 log 2 minus 5. Alright, so in this problem, I have 7 to the power of x is equal to 7. So to solve this, I'm going to first start by dividing both sides by 7. So then 70 divided by 7 is 10. So I have 7 to the power of x over 7 is equal to 10. Now if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 7 to the power of x over 7, 7 is the same thing as 7 to the power of 1. So I have 7 to the power of x over 7 to the power of 1, and that's going to equal 7 to the power of x minus 7 to the power of 1. Or sorry, 7 to the power of x minus 1, which is equal to 10. Now I'm going to take the log on both sides, so I get log of 7 to the power of x minus 1 is equal to log of 10. And if I have something in the form log a to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have log 7 to the power of x minus 1, and I can move x minus 1 to the front. So now I have x minus 1 times log 7 is equal to log 10. Now we want to isolate x, so I'm going to divide both sides by log 7. So these two cancel out, and I get x minus 1 is equal to log 10 over log 7. Now log 10, that's the same thing as 1, so I have x minus 1 is equal to 1 over log 7, and now I can add 1 on both sides. So I get x is equal to 1 over log 7 plus 1. Now, log 7, that's equal to 0.845. So now I have 1 divided by log 7, and that's going to equal 1.183. So I have 1.183 plus 1, which is equal to 2.183. Alright, so in this problem, I have x to the power of 8 minus 121 is equal to 0. So to solve this, I'm going to first start by rewriting x to the power of 8 as x to the power of 4 times 2. Now I have this minus 121, which is the same thing as 11 squared. Now if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 4 times 2, that's going to equal x to the power of 4 to the power of 2. Now this minus 11 squared is equal to 0. Now if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, this is going to equal x to the power of 4 plus 11 times x to the power of 4 minus 11 is equal to 0. Now this is going to equal x to the power of 4 plus 11 equals 0, and x to the power of 4 minus 11 equals 0. So for x to the power of 4 plus 11 equals 0, I subtract 11 on both sides, and I get x to the power of 4 is equal to negative 11. And for x to the power of 4 minus 11 equals 0, and add 11 on both sides, I get x to the power of 4 is equal to 11. Now, to solve this, this is the same thing as x squared to the power of 2 is equal to negative square root of 11 squared. And now this means that x squared to the power of 2, this actually has no solution because I have a number to the power of a positive x, to the power of an even number exponent equaling a negative number. So this is wrong. X to the power of 4 is equal to 11. For this, I can rewrite this as x squared to the power of 2 is equal to the square root of 11 squared. And now I'm going to subtract the square root of 11 squared on both sides. And now I get x squared to the power of 2 minus square root of 11 squared is equal to 0. And this means that x squared plus the square root of 11 times x squared minus the square root of 11 is equal to 0, meaning I have x squared is equal to square root of 11, and x squared is equal to negative square root of 11. For x squared equals square root of 11, x is equal to the fourth root of 11. And this has no solution, so this is my only solution to this problem.